Yeah, hi. Hottest lava ever recorded. I just googled that, and the first thing which came up was from the USGS. Very hot. Here are some temperatures recorded at different times and locations. The eruption temperature of Kilauea is about 1,170 degrees Celsius, 2,140 degrees Fahrenheit. The temperature of the lava tubes is about 1,250 degrees Celsius. I was doing some work on the papers I got yesterday, and I just somehow, in the first step, put them all here that you can see what all the shortenings means. K clearly means potassium, yes, for example. You probably, if you don't know them all, some of them you never could figure out. That's why I made it like that. And one thing I thought is about just checking basically materials, thermal behavior. What is the melting point of those things, what we have here? And let's just start with magnesium. Magnesium Wikipedia. Melting point 650 degrees, boiling point 1091. Okay. Next one is aluminium, which we have here. And now I'm just watching about the melting points and these kind of things. Melting point 660.32 degrees. Boiling point 2470 degrees. Really many. And then we have silica. Silicon dioxide. And they tell us that the melting point is 1713 degrees Celsius. Boiling point, almost 3000 degrees Celsius. Up next we have phosphorus. And it's melting at okay. Boiling point. Melting point 590 degrees about. Yeah, this seems to be a little bit more complicated. Boiling point 280 degrees. Phosphorus has several allotropes that exhibit strikingly diverse properties. The two most common allotropes are white phosphorus and red phosphorus. Okay. And after the next one, sulfur. I think I keep it. It is abundant, multivalent, and non-metallic. British spelling. Melting point 115.21 degrees. Boiling point 444.6 degrees Celsius. Critical point. Heat of vaporization. Mono, 45 kilojoule mole. Let's check it out. Joule per mole. Yeah, the moles. Is an SI-derived unit of energy per amount of material. Energy is measured in joules and the amount of material is measured in moles. For example, Gibbs free energy is quantified as joules per mole. It is also a SI-derived unit of molar thermodynamic energy, defined as the energy equal to 1 joule in 1 mole of substance. Yes, I'm not a pro, I really have to think about that, but it seems it's basically about the charge of the material itself. This very small amount of energy is often expressed in terms of a smaller unit such as the electrovolt. Whoa! Yes, but I won't bore you with that now because I leave it here. This is a start of digging into that, and I still would like really to know because here, this one is marked, but still we have 3 other ones, and I don't know what they are. Like all those lines here. This is really interesting. This one we know what it is, how it looks. But those 3 above, I have no idea. Some of them are really interesting, according to the numbers, but I don't know what they are. Zirconium. Quite much, I would say. I don't know. Strontium. Like also this one has. Yeah, I'm waiting for answers because I have already asked some people about that. But let's see. I just thought I'd share like stuff I do. Yeah, there's quite much work now to do. Finally, I got those results. Now that's really cool. And it really seems that those stones have been altered by really strong heat and stuff. So the question remains if there's no volcanoes. Nowhere here. Not even really real geothermal activity. How did it happen? How is it possible? I guess you know that I have my own theory. It's not my own, but that's what I wrote about. Yeah, it's really, really interesting. Even though I hate numbers, I really much more like to watch pictures than numbers, but what to do? Thanks. Bye.